This is Dr. Charles Parker, and you're listening to Core Brain Journal. It's a place where I connect both fresh discoveries and interesting different perspectives from advanced mind science with the realities of real people and everyday life down on Main Street. Well, welcome, folks. Here we are one more time. Dr. Charles Parker. This is Core Brain Journal. And I'm going to have to tell you, folks, you just have to get ready. I mean, if you're driving a car and you have your seatbelt fastened, that's a good thing. Because if you're just around the house or you're at the gym, I suggest you prepare to sit down and gather your thoughts, because we have a guest that is going to burn your ears off and light up your brain in all kinds of constructive ways. So welcome, Daniel. This is Daniel Schmachtenberger from Encinitas, California. Welcome, Daniel.
Thanks for having me.
Really appreciate you coming on board. I'm going to introduce him, and then we're going to hear a lot more about who he is and how he's thinking about the evolution of mind science. So Daniel Schmachtenberger is the consummate polymath with a background in systems science and human behavior, and is the founder of the Emergence Project. He's the anchor of the scientific team, as well as provides the vision behind the neurohacking movement at neurohacker.com. Now, some of you out there are saying, okay, guys, what is this whole neurohacker thing? I'm going to pass that one over to you, Daniel, and tell us a little bit about yourself and how you got into the whole neurohacking movement, please.
So, neurohacking pretty much means applied neuroscience. How can we work with various technologies and modalities to increase various aspects of mind-brain function, cognitive and psychologic function? And widely, it is technology agnostic, meaning whether we're talking about biochemical technologies or whether we're talking about neurotech kinds of technologies like transcranial stimulation, transcranial ultrasound, transcranial magnetic deep stim, TDCS, TACS, any of those kinds of technologies, or whether we're talking about brain training via neurofeedback or any other kind of brain training, or whether we're talking about genomic solutions in terms of either modulating gene expression or CRISPR technologies, or psychotherapeutic or any kind of personal development technologies, anything that is affecting the mind-brain system and the associated physiology environment systems that can optimize human experience and human capability, we're interested in.
Well, Daniel, I'm glad that you summarized it so succinctly, but you just covered the entire field of mind science in about 2 sentences. I think it's amazing that you were able to do that. But I like the idea of technology agnostic, because you're saying let's be inclusive. Let's not get all of our ducks in one row. Let's think about these in from a complexity point of view. And you and I had an opportunity to speak about this earlier. And I think that whole thing of complexity systems, if you could talk a little bit about that and how pulling these disparate ideas together might be constructive.
Yeah, when the field of psychoneuropharmacology started, complex system science was not well developed, wasn't really developed at all. And so our best scientific methodology was still variable isolation reductionism. So we're looking specifically to try and understand what dopamine does, or what a particular molecule that affects some part of the dopamine system, a presynaptic dopamine agonist or a dopamine receptor modulator, or some particular part of it, what that does. But that means we're trying to understand one part in isolation of the rest of the whole, and to be able to do clinical trials on that appropriately, we're kind of averaging everything else together, and then we see, do we get some kind of statistical lift beyond placebo? And if we do, then that seems interesting, even though that bell curve has people getting significantly different experiences on opposite ends of the bell curve. They're obviously attributable to other things, right? The way that one variable is interfacing with the rest of the system. And so complex system science allows us to look at a lot more variables, a lot more complexly, and look at their interactions and their synergies. Synergy defined as the behavior of whole systems that is unpredicted by the behavior of the parts taken separately in isolation. And so one of the problems when we are trying to isolate variables is the synergies between variables get missed. And this is why And the way we practice medicine, where we have gastroenterology, neurology, oncology, etc., all the diseases that start in one system and move to another system, right? Issues that start in the gut cause mucosal barrier dysfunction and end up causing neurologic issues. Because they're between systems, we end up missing so much of the pathology, of the pathoetiology. And what we find is also in radically complex systems, everything to various degrees interaffects everything else. So we need to study that, the causal interactions much more complexly. We also get causal recursion, where one thing can affect another variable, but then that variable can in turn come back and re-affect that variable, both either in a regulatory capacity or with positive feedback loops. And so obviously when we look at the success of psychiatric medicine for all kinds of diseases currently, compared to what a system that was truly adequate for addressing them would be, we have a huge delta. And the fields of integrative psychiatry, orthomolecular psychiatry, interdisciplinary approaches to mind-brain science have started to look at a lot more variables, right? Rather than just give a in-chain neurochemical modulator in the form of a med, look at why did that chemical get off balance in the first place? And really, was it just that one chemical, or is it a whole set of things that got out of balance? And did it originate in an inflammatory condition, in a gut condition, in a psychological condition, in head trauma, right? And then we also start to see that not only are there a lot of variables that are involved, but there are different sets of variables for different people. And this is where we start to get towards personalized medicine, and then personalized psychology, psychiatry, and personalized development. So say we're looking at anxiety or autism or Alzheimer's, and we're looking at all the things that we know causally are associated, right? Or at least all the things where we have some kind of correlation. And so we'll find maybe heavy metals are actually statistically meaningfully correlated with this particular kind of neurodegenerative disease. But so are other forms of organic toxins, right? Organophosphates, VOCs, maybe microbial imbalances in the mucosal system, maybe parasitic infections, maybe subclinical humoral infections, maybe methylation disorders, maybe certain kinds of psychological disorders. You see, all of these things are correlated, but not one for one, which means they statistically correlate. They probably have a causal influence sometimes, but not all the time, because that represents one pathway of deviation from homeostasis that can lead to pathophysiology, that can lead to some set of symptomology occurring. And when we talk about anxiety or Alzheimer's or any kind of disease, what we're talking about is some similar kinds of symptoms from some similar kinds of tissues, but the underlying pathoetiologies can be quite different. That's why we haven't succeeded in really being able to address them. And so you need to develop an underlying causal landscape, a causal ontology of all the things that could be associated, that could be causal, how to do differential diagnosis across all of those, and then how to be able to understand different therapies in terms of the underlying mechanisms that are involved. And then what is the weighted subset of that whole causal landscape that's going on for this person? And then what therapies, what synergy of therapies, and in what order of operations are going to be ideal for them? And this is where we move towards real personalized medicine, personalized psychotherapy, and then beyond the baseline of wellness, personalized enhancement and development that gets to synthesize the best of everything that we know to date.
You know, while you're talking, you say it so exceedingly well, and pardon me for being effusive with you a little bit, but it's just so interesting to hear you talk, because it's what so many of us struggle with every day. It doesn't matter whether you're a purely traditional psych or whether you're a patient coming into a psych office. Everybody's looking for the complexity really in their mind. They're thinking complexity, but they don't have a vehicle, a road, a path to consider and wrap their arms around complexity. And then
Right.
The additional thing with the complexity is not only the variables that you're speaking about, but is the complexity of time, as time comes into the whole situation, because so much of function is time related, and so much of what we're dealing with is not time related. It's find that label will be that way for the next 100 years. So.
Yeah, we also have, with regard to time, we have all of the conditions that have very delayed causation, delayed onset. And this is something that always makes diagnosis tricky, is if something has a rapid onset following a pretty clear cause, it's a little bit easier to treat. But if something has either a rapid onset but not following any clear cause, or maybe the clear cause that it followed was simply a last trigger of a whole causal chain that moved it into symptomology, then it's very easy to misattribute it. And so we need to be able to do diagnosis thinking about things that might have happened a long time ago but not resulted in symptomology.
Yeah.
And then as we're treating, of course, here's one of the things I would say is very deep to our goals is we have this internal regulatory system, right? This endogenous regulatory system. And it's not one regulatory system, but you can think of all the different regulatory axes as a comprehensive regulatory or cybernetic system. And we're regulating pH and redox interactions and glucose and neurotransmitters and all the things within specific ranges. So if someone's dopamine is really low and I just give them a in-chain dopamine agonist without asking why was it low? Was it low because they aren't eating enough protein that contains the amino acid precursors? Is it because they can't digest the protein because of a issue in their stomach? They can't absorb it because of an issue in their intestines? Can they not convert those amino acids? Can they not convert the tyrosine into L-dopa into dopamine? Are there enzyme deficiencies? So if I go straight to giving the in-chain agonist, then of course, whatever else was affected downstream, I'm not going to be supporting, right? And say it was a tyrosine mechanism. Well, that's also affecting their thyroid, right? It's also affecting so many other systems. And I'm going to get some side effects because now I'm creating a fixed level of that chemical independent of the body's real-time regulation of it, which is going to throw out the balance with the literally trillions of other chemicals that it should be interacting with more complexity than that. And I'm creating exogenous dependence, right? So rather than the body being able to self-regulate, it's depending on external regulation. And so now there's ongoing dependence. Our goal is that any good system of medicine and good system of psychiatry and good system of biohacking, neurohacking should be supporting the endogenous regulatory systems to have increased regulatory capacity. And we can really define health as the robustness and resilience of the regulatory capacity of the entire system. Wow. And then we can think about aging, actually, as decreased homeostatic resilience on some of the axes. And then we can think about disease as some deviations from homeostasis that exceed the homeostatic capacity of one or more of the axes that lead to pathophysiology. So then our goal really becomes, in preventing illness, in life extension, and in fundamental optimization of the human experience and condition, how do we increase the resilience, the robustness, and the anti-fragility of the entire set of regulatory systems? And a good intervention should seek to do that, right? It should seek to support endogenous upregulation rather than override it.
Well, one of the things that, as you're talking, I'm sure the complexity of your thinking is so fascinating. But you said something there just at the very close that I wanted to jump on, because what you're really saying, in a way, and correct me if I'm wrong, is that we're really when you're dealing with a complexity, you have a complexity of answers. You don't have a single answer. So one of the things that happens is people come in and see a guy like me and they say, I've got this problem. Well, how come I have to do all these supplements and these medicines and all these other things, because there's so many things? Can't you just give me one thing? And I'm a very primitive level of this understanding compared to where you are. But I think that's an interesting issue to address with our audience, because that's a frequent problem for our audience. How do we actually deal with the complexity on a street level?
Right. I would say the silver bullet mentality is a broken mentality in every area that we apply it, whether we're hoping that the answer to getting our finances together is a lottery ticket, or the answer to getting buff or psychologically well or anything. it always requires any kind of development of any system requires continuous, varied kinds of input. And entropy is always acting on systems. And so there is a minimum, and it's acting on all systems, right? You have oxidative stress on cells, you have excitotoxic stress, you have mutation that's occurring, and so since you've got entropy occurring on all these systems, you need to be putting in at least as much energy. And by energy here, I don't mean glucose energy. I mean putting in at least as much of the appropriate kind of input as is eroding, and to just even keep up, right? And just like anyone knows that if someone works out for 10 years, gets buff as can be, the moment they stop working out, they start losing it. And entropy is this just kind of universal recycling process of that which is no longer useful, right? And so then it starts moving those parts to be used for something else. So any kind of health, any kind of resilience requires continuous input and the appropriate kinds of continuous input. So we know that there are so many different minerals, depending upon which list you read of how many are essential. It's 72 or 84 or 92, right? But there's so many minerals that are essential for our health. There's so many vitamins, so many phytonutrients, so many macronutrients, and even a deficiency of one of them can lead to a debilitating disease, right? Just D being low leading to rickets, or C being low leading to scurvy, or B1 leading to beriberi. And so if we want to not see, it's not just them being low enough that they go into acute pathology. It's also the subclinical pathology of systems that are working, they're just not working optimally. And now we're not just talking about nutrients but we're also talking about input that supports detox and input that supports antioxidation and anti-inflammation, right? Which is not a nutrient per se, but it is part of what's going to support system regulation. So yes, I would say that anyone who wants to be really healthy and vital and optimized has to take full responsibility for what that means, and not expect that there's a very easy doctor solution or a single kind of solution, and just embrace that as the physics of the universe.
I mean, that is so absolutely true. I mean, that is what we deal with. Either we're going to deal with the complexity now, and some of us may be interested in how do we package the complexity, because people do have to understand the complexity. They can't just go out and shotgun the complexity, because that absolutely won't work. It has to honor the integrity of the system in some constructive way. And even though there is a complexity involved, that the integrity of that system has to have somehow be packaged in a way that the person on the street can actually, what's a good systems approach to that particular problem.
Right. When I think what you're doing with the podcast here is offering people education so that they can feel more empowered in what are likely appropriate avenues for them to dive deeper into. What we're seeking to do over at Neurohacker Collective is, we're developing specific technologies that can go direct to consumer right now. We're developing more that might not go direct to consumer, but be mediated by some kind of therapists. But what we're really looking to do long range is a platform that allows us to integrate all of the kinds of complexity, personalize them to an individual and their goals, and actually make the interface very simple for them. And so if we can collect all of people's biometrics, from their genetics to their clinical chemistry to their quantified self, sleep tracker, motion tracker, whatever, we can take all those biometric data pieces, and we can take psychometrics. We can do cognitive assessments that look at various aspects of cognitive function, and psychographic assessments, psychoanalytic assessments. And then not just look at each of those metrics in relationship to their own reference range, but look at each of them in relationship to each other. How did this particular picture arise in terms of factoring all of the underlying intercausal dynamics? Then we can start to get a real picture of what's going on for someone, and this person's sleep disorder different than this person's sleep disorder, right? This person's anxiety different than this person's in terms of underlying mechanics, in terms of the, genetics and fundamental space of that person, and then be able to synthesize what are all of the technologies that do have known efficacy for sleep, and then relate them to underlying mechanics or anxiety or whatever it is, and then be able to say these ones are going to be most effective for this person at this time, highest probability. So this is n equals 1 optimization. The clinical trial can't do that, right? It can only say there is some lift with a bell curve compared to placebo, even though the people on one end of the bell curve and the other are having totally different experiences. When you try to put everybody on the front of a bell curve, now we're not saying, okay, I have this device or supplement or meditation technology or whatever, I'm going to give it to everyone, and because I have a hammer, I'm going to say that everything's a nail, right? And we can say you have anxiety, so take a benzo, or you have anxiety, so do this breathing technique or meditation technique, and it might help some. But if the person's anxiety is related to a parasitic gut-brain axis disorder, neither of those solutions are going to fix it. And if it's related to head trauma, and there's some actual neural circuitry to address, none of those are going to fix it. But that doesn't mean there aren't things that could fix it, and it doesn't mean that they wouldn't show up differently if we knew how to do the right assessments, and then be able to direct people to, what is the highest probability of greatest success for them, which is actually now not that complicated. But it draws on all the complexity of everything we know, both about psychology, physiology, the mind-brain interface, and all of the diagnostic and therapeutic modalities.
So it has a simultaneous activity of ruling out and ruling in. So it's not just ruling out.
Right.
It's ruling in. And that's a very, very interesting point, because that takes us over to the affirmative prospect of how does this thing actually work effectively? As opposed to, here's what the problem is, here's how we can see this pathology. Okay, this is a sick, broken system. You're saying, well, that's really only a part of the picture. And if we get lost over there, which I think in truth many of us are, then we're arrested. We're developmentally arrested.
We have a lot of great insights, right? In the world of integrative medicine and functional medicine, I think, have been doing a good job progressively of trying to see how do we factor more systems. So we're going to look at the gastroenterology and the neurology and the oncology and the rheumatology together, right? And then we're going to look at the various intercausal worlds together, the genomics and the microbiomics and the transcriptomics and the proteomics and that way of looking at the body. And we're going to look at the different kinds of deviations from homeostasis, so toxins, nutrient deficiencies, genetic disorders, infections, right? And how do we work with those and try and make some sense out of this? And so you can see various people who are kind of at the cutting edge in those spaces doing a better job of synthesizing more things. Mm-hmm. Now, synthesizing and aggregating are different, right? Aggregating is the shotgun approach, which just says, all right, well, all these have some effectiveness. Let's kind of try all of them. Synthesis is, well, these ones are effective for these kinds of mechanisms, not just these kinds of in-chain conditions that can have lots of mechanisms leading into them. So how do we do the differential diagnosis and know what to do then for that person? And how do we do right order of operations, right? So if it's functional medicine gets into quite a lot, when you need to treat a gut barrier disorder before trying to address blood toxicity issues, otherwise you're going to or rheumatology, because you're going to keep having inflammation from tight junction issues or whatever. So I think they're doing a very good job, but they're doing it like you go to a conference and you look at all the cutting edge research that's happening in various fields. It's more than any human can actually synthesize. And when you look at all the medical journals that are coming out with actually good underlying mechanistic insights, it's, again, more than any human can synthesize, which is why it takes this kind of AI platform methodology to be able to vet and synthesize at scale and then make all of human knowledge available to individual practitioners and individual people.
Sounds like a Wikipedia of the mind. Putting it together in some constructive way. Yeah, AI is artificial intelligence.
Yes.
Just to say that, because I know some of our listeners may wonder what AI is. So then the next question after that is, you are developing a system then. You're developing ways of doing this, and you're codifying. And how, is this going to happen in a computer model of some kind? Is it going to be, it sounds like you're going in that direction, that when you feed the material in and you do a certain n number of tests, then you can feed it in and pop something out that's going to be more easily accessible than just plain thinking it through.
Yeah, definitely. So you can see that we already have labs that automate some of the suggestions based on kind of standard protocols from what they see in the lab. So you get the lab back, and you have, depending upon, say you're doing a gut barrier assessment, then based on what's showing up in the lab, you'll see some generated pages of common best practices. You also already have systems of electronic medical records that start putting some pieces of the data together, start giving you some analytics. So that's the trend in that direction. Those are just relatively low intelligence systems. And so what is interesting is, as we can start harvesting a lot more biometric data, then it becomes less and less understandable by an individual person in real time. So if we start doing whole genome sequences and want to look at the whole genome, right, that's a lot. And then it's not just looking at individual SNPs, right, individual genes and their polymorphisms. It's looking at the combinatorics on that. And now that scales very quickly. And then that still doesn't tell you about gene expression. And so then we're looking at clinical chemistry and metabolomics, transcriptomics, et cetera. And so, but we can understand the underlying mechanisms that are happening, and we can build systems to be able to model this better and do a better job of making more sense of more different kinds of data in a synthesized fashion. So that's the goal.
I mean, how can you say all of that in one breath? I mean, it's so interesting. So then how are you actually breaking that down in NeuroHacker? I mean, I don't want to ask for any proprietary, but just a little bit of an idea, because it sounds so very large to the questions you're raising are so enormous in terms of practical. How does one do that to make it simple?
Yeah. Well, if you go to neurohacker.com right now, you won't see anything about anything we're talking about. You will see a little bit of information on complexity science applied to neuroscience. And you will see some cognitive enhancement supplements for sale. So we're a relatively new organization, and so we're starting somewhere, like every organization needs to. Mm-hmm. And for us, while we knew the goal was, see, I'm talking about diagnostic methods here, but let's look at the therapeutic side for a moment. And you've got the disease model side, which is, how do we get people back to wellness from some diagnosed disease? But then you have the enhancement side. And so NeuroHacker has started, in terms of its forward-facing offerings, on the direct-to-consumer enhancement side. Mm-hmm. And if you think of neurohacking kind of as a subset of biohacking that is specifically focused, and that just means applied technologies for personal enhancement. But we're specifically focused on the mind-brain space. So enhancing cognitive and enhancing emotional and psychological, both well-being and capability. There's a lot of different technologies that are effective. As we were mentioning, so we were looking at whether we wanted to develop better systems of EEG neurofeedback or better systems of transcranial lasers for upregulating neuronal ATP, or better systems of computer-based psychotherapy, or that can work on a widely through a platform, or the better kinds of neurochemical solutions. And they're all very meaningful, and they're differently meaningful for different kinds of people. And so our goal was, to synthesize, to be able to have a space where if someone had a goal, no matter what the goal was in the psychoneural space, and no matter what the underlying physiology they had going on, there could be a best synthesized resource for them. And so we started in the nootropic space of cognitive enhancement because we'd worked in that space deeply, and we knew that we could do very potent life-enhancing things for people that were not currently available on the market. And we could do that easier than we could build this AI system. And so this was and then, from there, a whole line of direct-to-consumer biochemistry. So specific kinds of nutraceuticals that we didn't see on the market anywhere else, because we're working with this complex systems framework of not trying to say, all right, we have a sleep med and we're working with GABA or melatonin or, but what are all the things that are involved, and how do we upregulate the endogenous circuitry? And obviously to do this at full scale, we need to be able to do it in a customized fashion. And that's what requires this underlying system. So we're starting with not customized, but center of the bell curve, very effective for most people. And that's what we currently have. Then we're moving into phenotype specific. So before it's fully personalized, we find that there are handfuls of kind of neurochemical phenotypes. So like in the Walsh work you've looked at, under and over methylator is a different underlying structure, right? Under and over catecholaminergic, under and over cholinergic, CNS stimulation. So we can get more effective just through those kinds of categories, and then move into full customization. But it's also, of all the things one could do, how likely is a vagal nerve stimulator versus a transcranial stimulator versus this breathing technique versus these biochemical GABAergics going to be most useful for them even at that level. So we started building technologies in each of these categories. Some are in market already, some are still in R&D, and over the next year a lot will be coming to market. And this allows us to be able to grow our research team and continue development. And the underlying platform we're working on, but that has some years before it's meaningfully applicable.
Yeah. Well, the issue is because you're just going to have you're really in kind of a data acquisition mode, from what you're saying. Generally what the problem is, but then you're codifying and breaking it down and doing some serious data acquisition, because then you can push the button and have some configuration take place.
So yeah, we are, as far as data acquisition goes, not mostly in terms of feedback from current things we're doing. That's useful. This is why we do trials. But it is doing structured reviews of all of the fields to know where the current state of the art is of the entire field if you synthesize all the knowledge, which is something that is not, for whatever reason, commonly done or well done. And then being able to see what should our hypothesis generation within a particular space be once we already have looked at everything that is known in that space and what we can abstract from all those partial insights together. And as you know, if you're doing that in connectomics, if you're doing that in neurogenesis, if you're doing that in genomics, it's a lot of takes work.
Yeah, it's deep, and it's going to cost. I mean, to do that, to actually pull the laboratory data together, it's going to be. But if you have some interested people and some well-trained people, and people who are thinking along the same path, who have the same delightfully curiosity objectives that you have, it could happen. I mean, it's just a question of putting kind of a forgive the grandiose expression, kind of a new world order of how do we codify data, how do we pull it together.
Yeah, and the pull it together is the key part, because machine learning, assessing big data, is already there, and there's a number of systems doing that. But when the interactions are as complex as these ones are, even tremendous amounts of computation don't give us all the insights just via computational brute force. You have to actually develop models you have to develop underlying ontology of how this complex human regulatory system works, and then be able to utilize those models as ways of interpreting the data. Mm-hmm. And that's one of the things that we're kind of uniquely focused on.
Sounds so interesting. So when you go over to the website, you have some, I've seen them, you have some great videos that break down some of this. I mean, it's been a while since I was over there. You're looking like maybe you're trying to think of which video it was, but it seemed to me there was a video that I saw. It's like, oh my gosh, I had a very interesting moment. Am I misremembering that?
I do think we have some videos on the site currently. I don't know that we have any speaking about the future of, say, diagnostics or interpretation like this, but we do have ones that are discussing why a system science approach is needed, and then some of how we came up with this particular cognitive enhancement chemistry from a systems theoretic perspective. And because that's not only useful for interpreting diagnostic data, it's also useful building technologies that work across multiple mechanisms simultaneously and want to understand the synergy of those mechanisms. So when we're talking about enhancing people's cognitive capability, are we talking about modifying acetylcholine or glutamate or dopamine or other catecholamines or ion channels or changing the phospholipid membranes? Well, we're probably talking about all of those things, right? And then with acetylcholine, are we talking about changing how it gets across the synapse? Are we talking about changing how it is uptaken in the postsynaptic receptor? And so what we did in that space, because there were so many people who are not using Adderall via prescription, but off-label Adderall and other kind of what you would call smart drugs for their midterms, their finals, their tech startup, where it really does have meaningful side effects. And even, Red Bull and multiple doses of 300 milligrams of caffeine and it's important to get that both something like Adderall and both something like the energy drinks will enhance a certain element of productivity and focus while decreasing, statistically known to decrease, other key elements of cognitive capability, plus producing dependence, plus producing side effects. And so we wanted to see, can we support people in their desire to be more clear and productive and capable in the presence of ever increasing attention distractions in ways that are more effective and not harmful. And so that required us looking at, well, when people are really seeking cognitive enhancement, what are they looking for? And they're not just looking for focus. They're looking for a combination of focus and short-term memory and long-term memory and speed of memory and specific memory and digit span and verbal fluency and emotional things that come along with it, like emotional resilience and connection to drive. And so we kind of, from a cognitive science point of view, modeled what is everything that people look for there. And then we looked at what is everything known about the underlying physiologic pathways known to correlate with each of those subjective states and cognitive capabilities. Then there's chemistry that affects all of those pathways, and then start our design process from there. So that's, a systems theoretic perspective works both on a applied design science and a interpreting diagnostics in both of those worlds.
So the question then, as a guy who practices on a regular basis, and again, this is going to be sort of a proprietary question, but I'm curious because I use testing, and I wonder how a person like you or your team decides which group you're going to use for the test that you're going to acquire, so that it could have a more diffuse body of acquisition, so that a number of people can use it effectively. How do you actually decide what the laboratory is going to be or which laboratories to use? How does that happen?
Yeah. So as far as laboratory testing goes, I have to make my FDA disclaimer statement right now. We're talking about the future of medicine, psychiatry, just abstractly. But as far as Neurohacker goes, we don't have anything to say about medicine or psychiatry because we can't say anything about that.
Yeah.
And we aren't prescribing labs and et cetera. So we would just tell people to go to a doctor and get those done. But as far as research in that space goes, how would I determine what I think is a good laboratory test or not? Well, there's a few things. First, we have to look at sensitivity and specificity. How many false negatives, how many false positives do we have from that lab by comparing it to other known best of assessments over an appropriate database? So that's kind of pretty standard. Mm-hmm. And then we have to look at the turnaround time for getting the data back. We have to look at the cost of it and all other aspects of viability. And then we have to look at how relevant the data that it's showing us is. And what the interpretive confidence margin around clinical applications from that data looks like. Mm-hmm. And so, if we're doing parasitology and we really were just interested in, do we see the parasite, right? But if we're doing some immunology connected to parasitology and we're running CD57 to say that someone has Lyme's disease, but we know that it's not actually specific to Lyme, it could be all kinds of infections, then a CD57 for me means some kind of humoral infection usually, and that's about all it means, right? So I can use it as a indicator along with many other indicators for a complex set of assessments, but I have to be careful about how I interpret that particular metric. Mm-hmm. Now, as far as the platform that we're interested in, we want to make a platform that can upload any tests, right? So whether someone's comprehensive stool lab is coming from doctor's data or Genova or whatever, right? If the sensitivity and specificity is known to be high enough to have a meaningful confidence margin, we want to be able to upload any of them and be able to run data interpretation across them in the future. But it's also important to know that I'm very passionate about developing diagnostic technologies further, because when we want to do complex disease case solutions in particular, mm-hmm. I want to look at all of the inflammatory markers, all the autoimmune, all the rheumatologic markers, right? I want to look at all of the kind of nutrient markers. I want to look at all the genetics that I can see. I want to look at all the clinical chemistry, because it ends up being that even some of the more obscure things show up, and that you wouldn't have thought to be associated, show up in many of the difficult cases in non-obvious ways. And so to even say order of operations of which diagnosis to do first, which to do later, I'd rather get them all cheaper, all more reliable, and be able to just do a lot more data on everybody. And so there are kinds of technology that could make that possible, like being able to do metabolomics on mass spectrometry could make metabolomic assessment very cheap in the near future, right? Across 2,500 metabolites, be able to continuously run those. Things like, single drop of blood on a technology like gene radar is getting very interesting. And the next step beyond that is, I think, laser interferometry, where we can test a number of elements in the blood just through scattering patterns, diffraction patterns on laser light going in. You could imagine if that technology got very far, that we could be testing all of the biometrics nearly continuously, running big data on those, and you can imagine how much we could learn. So those are things that we see in the future of medicine.
See, that's an amazing picture, because what you're talking about is measuring, the things that you're measuring are phenomenal, because you're actually talking about all kinds of different pieces of the body, so to speak, anything from excrement to urine to mouth swabs to, there's a lot of biomedical variables in that whole situation that you were talking about, many of which I don't know about myself, because I'm just a commonplace practitioner. While I'm listening to you, I'm amazed, because I'm thinking of my own self-discovery process while I'm listening to you, and how I was going along thinking, hey, this really worked, but then it didn't work. So then I went into another level and say, oh, this works, but hey, here's another place with this new thing that I learned, but it doesn't work. So it's been one long process for me on a personal level of finding these different things out. It's why I value speaking to a person like yourself who has this depth of knowledge with these, like that whole thing of the spectral with the blood cell. What was that? What was that called? You had you're shooting laser into, was it
laser interferometry is there's very little that it can assess right now, and we're not sure how much we'll be able to assess, but I have a hope that the answer will be a lot. And so the deal there is you're actually just putting a beam of light, coherent light, into, say, your wrist vein, and then it bounces back. But based on what's in the blood, what molecules are in the blood, the frequencies of light will scatter. And they'll scatter differently based on different molecules and different densities of them. So you can tell blood glucose without taking a drop of blood, right? But then the question is, which molecules in the blood could we assess? And could it be a lot more of them? And could it be mostly all of them? And so whether it's mass spec on urine doing, metabolites, or whether it's the laser interferometry, or who knows, far out biofield assessments, I think what we know for sure is we will be able to get more and more data more often, more ubiquitously, so that we can understand patterns across lots of people, but even within a single person. And as that happens, it progressively exceeds the ability of individual people to understand fully without some aid in processing. Yeah. And that's where, as the diagnostic technologies get better, the interpretive technologies need to get better. And that's both the interpretive models that the doctors and people can learn, but also processing the data through those models.
So to translate a little bit, if you take some of these labs like Genova or Great Plains or whatever, and you find some level of confluence of successful information from them, that would just be a piece of what you're envisioning, because they would only cover the dimension that lab is skilled at measuring.
Right.
And so you have to then have a number of different, you have to have not one module, but you have to have several different modules that's just going to be worked up, and you have to figure out how to integrate and synthesize those modules into one I shouldn't say one answer, but one series of answers.
Right. So I'm not a doctor. I'm a researcher, but I've worked with a number of integrative doctors on difficult, traditionally incurable cases, and so we looked at what are all the things that the literature knows is essentially correlated, and then how do we assess for those? And that would look like I would have a relationship with one lab to test mycoplasmas, and another one to test viruses, and another one to test parasitology and protozoas, and another one for the best rheumatology, and other ones for scans. And that was actually usually several different types for different kinds of brain scans, and other ones for mucosal barrier function, right? And other ones for mold and biotoxin information, other ones for environmental toxins. And so what that means is that's just so burdensome on the clinician and on the office staff to have to set up all those relationships and send them different places and spin the blood this way and et cetera, that we really need the field of diagnostics to get fundamentally better. Otherwise, some diseases are incurable that aren't really incurable simply because what it takes to figure them out is too hard.
That is so true. We see that every day. I mean, the whole spectrum of how you actually just get the test taken care of. It requires, forget managed care and answering it to myriads of people in managed care with high school educations. The thing below that is, how do you just fill out the paperwork and get the laboratory information back to pull it together, and then how do you spend the time to put it together and get and put together a program for a person? Yeah, it's
great.
It's definitely difficult right now. While you're talking, I was thinking about an experience I had with some really interesting neurofeedback people when I had the office up in D.C. doing near-infrared hemoencephalography. When you were talking about that particular technique, because even now, and people out there need to know that you could put a band on and shoot red infrared spectrums, near-infrared hemoencephalography. You can shoot it right through the skull, have it bounce out, and get readings on what's going on with the oxygenation in the prefrontal cortex.
Yeah.
And that's there. That's here right now, and it's not difficult to do. I mean, the technology is pretty doggone simple to do. To acquire, I should say.
It's true. Well, yeah, I mean, that FNIR technology is pretty simple, easy technology. And EEG is becoming simple enough that home EEG units are actually meaningful data sources. Mm-hmm. And home HRV units are good. And so this is what...
HRV, what's the HRV?
Heart rate variability.
Okay. Mm-hmm.
And so which is a major indicator of autonomic nervous system. And so this whole field of what we call quantified self, the various kinds of devices that allow self-measurement, I think is going to be a huge part of the future of medicine, where people take more and more responsibility for their own well-being. And this means that already people have the ability to buy their own supplements and do a number of their own therapeutic modalities, but they also then need to be able to track, right? If they really want to understand what's going on. And so I think both of those are increasing.
Yeah, track it over time, because then they're going to be able to do that assessment, and then that'll be somehow hooked back to your database of, hey, it's working, or no, it's not. And if it's not, what do we do next?
So this is in the dreaming phase for us in terms of all the things that platform will be able to do. But we do hope that it gets to the place where we can do the kinds of complex data processing we're talking about. And included then is, if there is data missing that we would need to be able to figure it out, that we can actually recommend what kind of diagnostics people get. We could recommend doctors for them to go work with in a network. But we could also be able to recommend which of the home assessment technologies are best from vetting them, so that we're empowering people to have more ability to participate in their own well-being.
Now, that's a reason for all of our listeners to go right over to Neurohacker and get hooked up immediately, because they need to be on your list right now. Because if you then have next week or next month or next year some way of beginning this process of measurement that you folks have signed off on, that you think is going to be valid and useful, then they need to be there. I mean, our whole audience, ours is a small audience. I mean, there's a bigger audience out there that's curious about this, but I think anybody that ever listens to this should be just immediately hooked up with Neurohacker. I'm quite enthusiastic about having had the chance to speak with you, because what you're talking about is where I think so many people want to be, but don't know how to get there, myself included. I think, it's such an interesting place to be, and to even envision the possibilities are there, because the mind has seemed, completely out there. It's just, we can't even talk about it. It's just over our heads, nothing to talk about, all these different things. IgG is still complex. And as mundane as that simple test is, a lot of people, it's a belief system to some. It's this Galileo moment. The sun is rotating around Rome. I know it is. I can see it is. So we don't need to worry about that. And that is what's going on. So we really do have to close, Daniel. I know you're a little bit under the weather, and I can't tell you how much I appreciate you taking the time to join us here and be with our audience. I mean, this is going to be one of our most outstanding interviews, because why? Because people are going to have to listen to it more than once. Because you are so deep and so interesting that people are going to share this and really be interested to learn more from you. So thank you very much. I appreciate it.
Dr. Parker, I have so much respect for what you're doing, and it was a real honor to be here.
Thanks for listening to Core Brain Journal. We're working every day behind the scenes to bring you reports that connect research benches with those street trenches. Here we share the complexity of mind science because, as you know, details really do matter. One of the most pervasive, misunderstood challenges is how commonplace medications, like those written for ADHD, are used so regularly without clear guidelines. If you think you'd like more specifics, take a minute to download my 2-page PDF packed with video links and references on the absolute essentials of how to start ADHD medications. They're easily available at corebrainjournal.com/start. Thanks for listening. Do connect and stay tuned. Together we can make a difference.